Hello again. We're going to look at section 7.1, part 2, some video examples here. We're going to look at sample size determination. Here we're going to find out how large a sample needs to be to achieve a specific level of accuracy. All right, I'm going to jump over to the examples. So hold on here while I take care of this. And there we go. All right, so sample size determination. A sample needs to be selected to approximate a population proportion. So we want to determine the sample size needed to be 90% confident, so that's our level of confidence, that the margin of error, that's our E, is no more than 5%. Now, once I've identified that, in addition to that, I've got to determine if we have information on possible values for P and Q for the population as a whole. Here, we're going to assume that there is no data on P and Q. Now, once we've done that, I'll need to go ahead and remember that I'll have to use the formula N equals Z alpha over 2 squared times a 0.25 divided by E squared. Now, the Z alpha over 2 is a critical value, and we're going to go ahead and pick that up from the inverse normal 83 program. So once I do that, then I'm going to go ahead and plug that value in. I'll note that E is 0.05. That's the margin of error. So the important thing to do is to find that value for the critical value Z alpha over 2. So I'll turn on my calculator. Under program, I'll find the inverse normal, plug that in, and whenever I find critical values for sample size determination, it's always a 2 equal tail question. Now, the total area of the two tails is set by the 90% confidence interval. This is the 90% that's stuck in the middle, so to speak, of that normal distribution, which means we have 10% or 0.10 bits of area on both the left and the right tail. I'll get two critical values, plus and minus 1.645 and a negative 1.645. Which one do I use? Well, first, I'll note that I do not need answers in terms of X here. It's strictly a Z value question. So I'll also note that the Z needs to be squared, so it really doesn't matter which one I pick. So I'm going to use the Z alpha over 2 equals the 1.645. Now, I have everything to plug into my formula. We have the 1.645 squared times the 0.25. You'll find in your notes in the text and in the PowerPoint presentation where that 0.25 comes from. At the end of the day, it's an assumption about P and Q being equal to 0.5 each. Now, the denominator, 0.05, and again, squared. Common error is to forget to apply the square to the Z and the E. Mr. Calculator comes back to help. 1.645 squared times 0.25 divided by 0.05 squared. Order of operations doesn't cause any issue or trouble. And there we go. Now, there is a rounding rule for the sample size determination. If I have a decimal there, some sort of part of a whole, I always round up to the next highest whole number. In this case, 271. So the sample size in this case is 271 individuals will be selected. That will get me within 90% confidence that I have a 5% plus or minus handle on the true population proportion. Another example. What percentage of adults shop online? and how many adults must be surveyed in order to be 95% confident that the sample percentage is in error by no more than 3 percentage points. We're going to assume that a recent poll showed that 80% of adults have made a recent online purchase. So my level of confidence will give me my Z alpha over 2. 3 percentage points, that's my margin of error. That's 0.03, and we'll note all this. Now, I do have some data, P and Q. Now, I'll remember that when I have detail on P and Q, I'll use a different formula. So, the Z alpha over 2 I'll go for first. Two equal tails. 5% is what's left for the two tails for my 95% level of confidence. Plus or minus 1.96. So I'll take the positive one, 1.96. My margin of error, 3 percentage points, 0.03. P, 80%, or 0.80. And I'll remember that gives me Q also. And there we go. So now I've got everything to plug into my formula. It'll go in exactly as it looks. And once again, the order of operations will not pose a problem. Mr. Calculator comes back to do the hard work. Times 0.8 times 0.2, and we'll divide that all by 0.03 squared. So 682.95 and some change. 683. So the sample size that we will shoot for is 683 individuals in our sample. And I will note that all of this is done prior to any sample being taken. You really need to determine how much data you need before you go out and look at that. Thank you. That's the end of 7.1 video examples, sample size determination. I hope you found that helpful. Please reach out with questions and concerns.